Hi, thanks for joining me. Today I'm going to be computing the integral from minus pi over 2 to pi over 2 of x sine x over 1 plus e to the x dx. The trick is to do a substitution, u equals minus x, and so we get du is minus dx. This integral, the limits are going to swap around, so we've got the integral from pi over 2 to minus pi over 2 of minus u sine of minus u over 1 plus e to the minus u, and dx will become minus du. First things first is I'm going to swap this, or cancel the minus sign to swap these limits around. So I get the integral from minus pi over 2 to pi over 2, and then just a du. And I'm going to use the fact that sine is an odd function, so I can bring this minus sign out, and then it's going to cancel with that guy there. And so we're just going to get u sine u over 1 plus e to the u du. Now, e to the minus u, sorry, on the bottom. I'm going to multiply top and bottom by e to the u, and this integral here becomes the integral from minus pi over 2 to pi over 2 of e to the u sine u, all over e to the u plus 1 du. Cool. Why have I done this? Well, now these integrals look pretty similar. And remember, u here is just a dummy variable. I could replace u with any letter I wanted here, including x, and this would still be true. And so the trick to working out this integral, if I call it I, is to add these two integrals together. So if I do that, of course, I'll get 2i, and the limits are the same, so I can just bring them all into one integral, and the denominators are the same, they're both 1 plus e to the x, and both numerators have an x sine x in them. This guy is just one lot of it, and this guy, there's e to the x lots of it, so sorry, plus e to the x, and dx. And the beauty of this is that guy entirely cancels with that guy, and you're just left with the integral from minus pi over 2 to pi over 2 of x sine x dx. But this is pretty straightforward to integrate using integration by parts. It turns out that this integral is minus x cos x plus sine x, like so. And cos is very nice. When you plug in pi over 2 and minus pi over 2, it's just 0. So this is just going to be sine of pi over 2, which is 1, minus sine of minus pi over 2, which is minus 1. So 1 minus minus 1 is 2. So 2i is 2. And so that means that I must be, I must be 1. So this integral here, the integral from minus pi over 2 to pi over 2 of x sine x over 1 plus e to the x dx is just 1. And this is how we prove it. I hope you have enjoyed this video. Thanks for watching. I'll catch you in the next one. Have a great day.